module, you will learn about electric circuits. The electric current in a circuit is due to potential difference between two terminals of the battery. Let us consider the analogy of flow of water. Water in a perfectly horizontal pipe does not flow. Water in the pipe is stagnant as the level of water in both the reservoir is the same. If we raise the level of water in one of the reservoirs such that there is a pressure difference between the two ends of the pipe, water flows into the other reservoir. Similarly, flow of charges in a conducting metallic wire takes place only if there is a difference of electric pressure, called the potential difference, across the ends of the conductor. This difference of potential may be produced by a battery consisting of one or more electric cells. The chemical action within a cell generates the potential difference across the terminals of the cell, even when no current is drawn from it. A closed loop through which charge can continuously move is referred to as a closed circuit. If the loop is not complete, then charge stops flowing, and such a circuit is known as an open circuit. When the cell is connected to a conducting circuit element, the potential difference sets the charges in motion in the conductor and produces an electric current. In order to maintain the current in a given electric circuit, the cell has to expand its chemical energy stored in it. Constructing an electric circuit can be a complex task, as a circuit uses various kinds of electrical components. A diagram is drawn to represent the components and flow in a schematic form. This schematic representation of various electrical components using suitable symbols is called a circuit diagram. In this module, you will learn about electric circuits. The electric current in a circuit is due to potential difference between two terminals of the battery.
Take a zinc plate and a copper plate and keep them on the table. Take an electric bulb with its holder and place it near the plates. Connect one terminal of the bulb to the copper plate using a connecting wire. Connect the other terminal of the bulb to the zinc plate using another connecting wire. Take a beaker containing dilute sulfuric acid and place it on the table. Now, carefully dip the copper plate and the zinc plate into the solution. Ensure that the two plates do not touch each other. Look at the bulb. What do you observe?
Module.
Take two batteries and insert them in a battery holder. Using a connecting wire, connect the positive terminal of the battery to the positive terminal of the ammeter. Connect the negative terminal of the ammeter to one end of another connecting wire and leave the other end free. Let us call this free end P. Using another connecting wire, connect the negative terminal of the battery to one of the terminals of the plug key. Connect the other terminal of the plug key to another connecting wire and leave the other end of the wire free. Let us call this free end Q. Using a sandpaper, remove the insulation from both ends of all the insulated copper wires. Take an insulated copper wire of length 0.5 meters and thickness 0.5 millimeters. Connect it between the two ends P and Q. Connect the end P to the positive terminal of the voltmeter and the end Q to the negative terminal of the voltmeter using connecting wires. Now, insert the key in the plug junction to close the circuit. Note down the ammeter reading I and the voltmeter reading V. Record your observations. Remove the key from the plug junction. Next, remove the copper wire and connect another copper wire of length 1 meter and thickness 0.5 millimeters in its place. Again, insert the key into the plug junction. Note down the ammeter reading I and the voltmeter reading V. Record your observations. Remove the key from the plug junction. Next, remove the copper wire and connect another copper wire of length 0.5 meters and thickness 1 millimeter in its place. Again, insert the key into the plug junction. Note down the ammeter reading I and the voltmeter reading V. Record your observations.